Are you recording? Are you recording? Okay, good. This is Hammer Drill 101. So come on in close. We got a pack out kit here, Milwaukee pack out kit that goes on our carts, locks onto our cart system, and we put all the hammer drill necessaries inside here. So first of all, the drill itself, we have a cordless Milwaukee hammer drill. There are a lot of corded drills out there that are probably the most powerful versions. The great thing about this is we can go on location, we can be out in the baseball fields, and we've got cordless power to do this with. We also have, some of our drills have a hammer drill function on them. And so depending on the drill you have at home, it may have a hammer drill option, and we'll talk about that in a little bit. What we've done with the kit is we put everything we need inside to fasten into masonry applications. Masonry being brick and block walls, concrete floors. All of those require a percussion style bit to break through the material. So we've got all of our drills in here. All of these drills are going to be SDS style, and that is slotted drive system. Now these drills will chuck into a standard drill because they are round as well. There we go. You could use this on the hammer drill setting. The percussion comes when we push against the back of the drill. And what's happening here, if I can go slow enough, you can see that it's jumping in and out slightly. And that movement in and out is the percussion or the hammering against the block or brick that actually busts it up. That actually busts it up as it rotates. If you're doing serious application installations, a lot of them, not just hobbyist or occasional, this drill probably won't handle what you need. You want to go to a slotted drive system. The slotted drive system, what happens with this drill, the slots allow the drill bit to move a lot within the quill or the chuck. And in order to install this, you're going to rotate this until it drops into place. And then you have to pull this collar down and it will lock in. And now it has a degree of movement, let's say 3/8 of an inch back and forth or fore and aft. And if our hammer drill is turned on here, then when we rotate this, you can see that pulsing in and out. And it's pulsing significantly more, and it's just gonna hit a lot harder. Full speed, the thing is vibrating all over the place. It's hammering into the wall as the drill is rotating and cutting. These are a carbide tip here, so high carbon tip. This one's a little worn, but they're not super sharp like a regular drill bit would be. Again, they're just basically punching into that wall and punching through it. So to release this bit, if we need to change out the size, this happens to be 3/16, we would pull the collet down here, and then it allows it to slide out. Actually, let's talk about fasteners next. Depending on what you are fastening into, we've got all kinds of different options here. These are called lead nail-ins. These would require a 1/4 inch diameter drill and hole. Once we drill the hole into the wall, we hammer this lead, we put the insert in there, hammer this in, and it expands, and that's what locks it in place. It's a one-time application, very difficult to get out. If you had to remove it, probably is not happening. These require a 5/8 drill bit, if you can see that fraction right there. And they would be for a 1/4 inch lag bolt. So if you watch what happens when we thread the lag bolt into this insert, let's say we drill the 5/8 hole in the wall, we put this into the concrete wall, then we go with our lag bolt, and what's gonna happen is that's going to expand slightly, and that pushing against the concrete hole outsides is what keeps this lag bolt in. The advantage of this is you can remove it, install it, uninstall it, and make some adjustments with it. Okay, next up, these are commonly called red heads or wedge anchors. So you would drill a 3/8 inch diameter hole, and actually we can see that right here. Drill bit size is 3/8. The hole needs to be about a 1/4 inch deeper than the length of your insert. And what happens down there, if you can see that picture right there, is the wedges, it goes in this way. These wedges expand against the tapered bottom here, and as it pulls up, then it'll lock in place, and you have a stud sticking out of the ground. Let me give you an example of why you would need that. OSHA, Occupational Safety and Health, came in and saw our drill press here is freestanding. So it is not anchored to the ground. What we would need to do is hammer drill these anchors or pre-drill holes into the concrete, stick these anchors in, and then fasten them down into the concrete. That's how this would be installed properly. We need to do that in order for OSHA to say, okay, that's safe to use. Okay, jumping back to our fasteners. These are called Blue Rock anchors. And important on these is when you get a box of these, you need to hold on to the box because the box will tell you what size fastener you need. For example, this is another good habit is to tear off the front label of the fastener box. In this case, these are Blue Rocks, or Tapper Plus is what they're also called. They're 1/4 inch diameter by 3 1/4 inches. The drill size that you need for this is 3/16. So we're going to use these, I believe, to do a little installation application. And I'll tell you that this can get confusing and difficult. If you just find these anchors sitting randomly, these are 2 different diameters. And if I didn't know that this was a 1/4 inch diameter, I wouldn't know that I had to use a 3/16 pre-drill. Taking a look at the size difference here, we'll just pull a new one. 3/16 by 7 SDS plus. That means that it's slotted drive system plus. On our drill, we want to verify that our drill is an SDS plus drill. So we can look right here and we see that it's a rotary hammer that accepts SDS plus drive system. So now to install our bit, we're gonna put this in, rotate until it drops in, then pull the collet down. Now it's locked in place. If we look at the difference in diameter here, this is a good, really good way if you're not sure. The diameter of the drill bit should be slightly smaller than the diameter of the screw, or we can see that the flutes of the screw are what's grabbing. So that's one really rough way to go. Well, if I'm not quite sure and this is what I've got, I could put it together. But the best way is to look at the front of that label and make sure, oh, this is a 1/4 inch screw. We're going to be using 1/4 inch diameter by 1.5 inch length screws for an application, okay? A few other items on the drill here. Number one, we've got our M18 batteries. We got enough juice to drill some holes. This has 3 different functions on it. The first function is a chisel function, which creates linear motion without rotation. So you can put chisels in here and use them to chisel up flooring substrates or like glue or clean off surfaces. It works really cool for that. A lot of people don't use it for that. This would be hammer drill. So we get rotation and percussion. And the last one is just a drill setting, like a standard drill, which I don't know where you'd use that with the masonry bit that often. So typically we're going to be on hammer drill setting. Last thing is the T-handle here is to allow you to get more force on the wall. Rotate this counterclockwise or lefty-loosey. That will allow you to spin to an angle that you're comfortable with. Then rotate clockwise and tighten that up until it will not rotate anymore. Okay, we're going to go to an application setting next. So we are backstage of the theater right now, and an observation that I had, bug list or Kaizen improvement, was that we have a broom back here, which is great, but the broom's always leaning up against something, and then once in a while the stick falls down and it becomes a trip hazard. There should be a home for these items, broom, dustpan, etc. Well, we happen to have some of these bars available. They were surplus or overrun when they built the new high school. And these bars work really cool as broom holders. So this one happens to fit really well right here. And the way that these bars work, oh, it's upside down, let's try this one, is you insert the handle in and it locks kind of marine-like and holds our broom up off the ground. Now, we need to do a little bit here before we drill holes in the wall. First of all, why do we need a masonry application? This is a concrete wall. These are set in place. They're usually 8 or 10 foot segments. There's a joint right here that you can see. And there's a locking interlock right there where it looks like it was kind of schmoed together. And all of these walls are brought in separately. They're really long, 40 feet, let's say, whatever the height of the ceiling is, stood up separately and then locked together. Solid concrete. Masonry block would be another application. I'll take a look at one more application outside, some brick. If we were installing into a masonry application like this brick, we would want to pick the bed joints here or the head joints to put our anchors into whenever possible. The brick is much more brittle and it will tend to split. If you have to put a hole in it, you just kind of be really ginger and take your time. Try not to create a lot of heat. Ceramic tile is even worse if you have to drill into like a tiled application like a bathroom or tile walls. They want to split, and there's much more technique involved in that we're going to go into in this video. Okay, so to install this properly, first of all, we're kind of mocking this up, getting a feel for, okay, what's a good height here. Works out great that the box comes out over these controls here, that we can still access those and that they wouldn't get in the way. And I'm assuming we're going to put some dust pans and such up here. So the only question would be, would we want to go down here and lower? Would there be any reason to go lower for some of the lower items? And what's your opinion? Higher or low?
I'd put it above.
Okay. So we're going to go up above. Next thing we have to figure out is if we want it about here. There's a few ways to do this, but how would we make this level? We could use a level. It's important that we install this level. We shouldn't just guess or eye it. What we can do is strike a line here to where we know we want it to be on one side, and then we're going to level it in. So we could use a 4-foot level, and as long as everything is easy to hold here, we'll make our adjustments. Not much, huh? Across that top as well. I wanted to show you a couple other techniques. If you were the only person doing this, you could cut a length of material, scrap material, and use that as a prop, or even 2 props to hold this up in place so that you can mark it exactly where you needed it. You could also pull a tape measure, measure up to a point, make a mark, go over, measure up to a point, make another mark. We got a lot of variables here. We just eliminated our level variable. We are now level, so we're going to mark these holes for drilling. There's 1, 2, 3 is overkill to hold this. We'll go with the 4th one in the center here, just because, America. I want to make sure my marks are in the centers of these holes. These holes are they're really small relative to the fasteners. We could oversize the holes in the steel so we had more room for the screws. We've got marks on the wall now. Masonry bits don't necessarily start easily. They'll want to wander a little bit, so we're going to try and pay attention to this closely. I'm going to get some safety glasses on, and then we will drill these holes. They were in my tool belt. What do you know? Okay, so this only spins. It does spin directionally. So I do have directional control here. This will be spinning counterclockwise, which would be the wrong way for these drills. I want to go clockwise. I'm going to pay real close attention here to where this is starting. Center that. Push in. Oh, it just dropped in. The slotted drive dropped in. As we pull the trigger more, we can see that percussion blast that out of there. So I want to make sure that I'm as straight as possible. Now these do get hot. If I can pull this out, I cannot. So, one method here would be to mark the bit. The reason I would do that is I want to know how deep it is. I can see on the dust here I'm plenty deep for the screws that I'm going to be using. So plenty far. I've got a mark now to know where to go to. Could run a piece of tape around it as well. That's a good way to indicate how deep. So come on here and look at this one. In this case, when it first started drilling, it's off of my mark. So I want to shift that. I can do one of two things. I can try and get it started where my mark is. See if it doesn't wander back into that hole. If it wanders, then I'm going to go down into the left so that the drill starts up and right. There. Now I've got it moved back to my mark. Whoa. So as I was drilling, I was observing there's a lot of dust coming off of there, and we want to be really conscious of that in this environment. So much so that if we've got a cordless vacuum, we might as well use it. Of course, we would do cleanup after the fact, but we can even run this drill while we are drilling if we can be coordinated enough, or if we've got an assistant. I'm going to turn this on. Go to my last mark. Now I'll do a little cleanup. Now I'll do a little cleanup. Something that bugs me is when people leave a trail of their work. The leave no trace concept should mean that we can see that it was installed, but we don't necessarily have to see that obviously somebody used a hammer drill and they walked out of there. We don't have to leave that trail. We can work clean, and that allows us to do our best possible work. So to install this, we're going to need some nut drivers and a drill. We'll grab those. Our holes are really close. Let's see how we did. Of course, I don't have the drill that I need. So our blue rocks have a 5/16 socket head. We're going to use a 5/16 nut driver on a drill. I would go for the center hole first. I better make sure that I install this the right direction, because it only works one way. The shafts of the brooms are going to go up and in and lock in place, so I know that's correct. I'm going to get my middle screw lined up here. I won't install it tight. Go in a ways like this. I can let go. I want to get my other screws to start before I would run all of them in tight. Just a good habit. If there's any room for wiggle, I need a little bit more of a extension on this, but I might be able to make it work. I'm going to clutch my drill down to like 6, just so I don't over tighten here. That's not enough to drive it. Tight. Get the drill out of the way here. Tight. Tight. And I need one more. And we get the satisfaction of installing the broom on the holder. Scene.